Okay. Good morning, good afternoon, and good evening, everyone, wherever you might be. And today we're going to be doing some exercises on basically equations of planes. So, like what we did in our previous video, is we talked about how we can sort of construct and work with equations of planes in 3D and how that relates to lines and basically stuff like that. So, yeah, let's just get right into it. So, number one, let me just move my head. Number one tells us to, well, find an equation of a plane. So that's going to be our task. Am I sharing the right screen? Okay. So we want to find an equation of the plane. And now that plane has some characteristics. So the plane passes through the point 201. Oh, 201. And it's perpendicular to some line. And that line has parametric equations of x2t, y is 8 minus t, z is 3 plus 7t, right? Okay, now first, when we want to find a plane, we basically need a normal vector and some point. We actually already have the point, which is this thing. Now we just need a normal vector. So that's what we're going to do. We're going to find a normal vector, which we'll just denote as n. How do we find that? Well, we're given other information here that the plane is perpendicular to this line. So kind of like we have a plane. Well, that's weird. We have a plane and we have this line and it's perpendicular, and that line has parametric equations of x, y, and z. So actually, we already have our normal vector here. Why? Because that normal vector has to be perpendicular to the plane, right? So imagine this was our plane. This is not drawn to scale. We need to have a normal vector that kind of goes up or down and it's perpendicular. And we actually already have our line here. We have our line and it's perpendicular. So that means our normal vector is these numbers here. So that's n, 2 for our x, -1 for our y, 7 for our z. Now we just use a formula for equation of plane. So that formula is we have a some x value and initial point plus b plus c. So it's really all about just recognizing these stuff, memorizing the formulas, and then just plugging it in. So we already have our n here. So I'm actually gonna kind of do this so that we know what we're talking about. A, B, C. So that's that. So A is 2, B is -1, and C is 7. And then we already have our initial point. So our initial point is 201. So I'm also gonna put that. So our initial point is 2, 0, 1. Was it 1 or -1? Oh, it's 1. Let me check. I might be wrong. No, I'm right. Okay. Now we just plug it in. So we have a, so 2, x minus 2, because x naught is 2, plus b, which is -1, so we do -1, y minus 0, and then c, so plus 7, z minus z naught. So z naught is 1. And that gives us an equation of a plane. Done. Now, we can choose to simplify. I'm not going to simplify. It's okay. So I'll just plug it in, see what happens. If I get it wrong, that'll be fun. X minus 2. Yeah. Minus, honestly, I could just do minus y, but that's fine. Y minus 0. Then we have plus 7, z minus 0, or was it z minus 1? Z minus 1 is equal to 0. So 2 times x minus 2 minus 1 times y minus 0 plus z times z minus 1 equals 0. I think that should be it. Yep, we got it. Next. Another find an equation of a plane. Find an equation of the plane. And how does this work? Well, we're again given a characteristic of the plane, so it passes through point 7, -2, -3, and this time it's parallel to the plane, which has an equation of 5x minus y minus z is equal to 5. So what do we want? If it's parallel, so again, it's the same steps. We also want to find a normal vector, and then we want to plug in we want a normal vector and a point. That's always what we want for a plane, a normal vector and a point. We already have a point here. It's this one. So that's done. Now we need a normal vector. And where can we get that? From this other piece of information that we're given. So let's imagine we have two planes, and it says that these two planes are parallel. So meaning, I don't know if this is a word, they're equidistant to each other. No, I'm kidding. They're not equidistant. They're never gonna intersect, right? So what does that tell us? Well, that tells us if we were to have a vector on one of them, one of the planes, I don't know, that vector goes left, then probably the vector on the other plane is also the same thing, right? It's probably also the same thing. Okay. So if it's the same thing, then we can already use that to find our normal vector. I don't know if it has to be parallel. Let me double check. I'm not sure. I don't think so. Oh no, look. No, it's different. Oh, okay. So their normal vectors are the same, but I drew it the wrong way. Yeah. Basically, if we had, yeah. If we had two parallel planes, sort of like this. Oh, that's parallel. then their normal vectors, which are perpendicular, is probably the same. And so we can actually see the normal vector from the other plane that's parallel, which is here. And where is that? Well, it's this one. So again, we want to find normal vector, which will just denote as n. Okay, next time I'm not going to forget the ABC. So this is just 5, -1, -1. That's it. Right? This is that same formula with the ax plus by plus cz plus d equals 0. Yeah, it's the same as that formula that we derived in our previous video. Yeah, it was in a previous video. So that's our normal vector. Now we have our point, so let's just use our formula. So I'm not gonna write it down anymore because I have it here. So we just plug in everything. So it's just 5x minus x naught. So that's 7 plus, or actually it's minus because it's negative b. So plus b minus 1 y minus -2. So that's plus 2. And then c plus c, so minus 1 again. Z minus -3. So it's minus -3 plus 3, which is equal to 0. That's it. We're done. We can simplify, but I don't want to. So 5 times x minus 7. Then we have minus 1 y plus 2, I think. Then we have minus 1 z plus 3. And that's equal to 0. So 5x minus 7 minus 1 y plus 2 minus 1 z plus 3, 0. Yeah. Okay, let's hit submit and see what happens. Okay, we got it. Next. Now, we're given another one, another find plane equation. Okay. And what is this plane this time? Well, this plane passes through 3 points. So it passes through this point. Probably should name it. Doesn't matter. 5 minus 8, 6. You know, I'm gonna name it. I'm gonna say point B. I'm so used to naming everything here. Then let's say the other one's Q. And then the other ones are PQR. Yeah. Now we want to find that equation. So again, we already have our initial point, which is P. Could be Q, doesn't matter. Now we need a normal vector. So how do we do that? Well, we need to find, so this point is in the plane. So imagine that's our plane. We don't know what equation it is. This point P is in our plane, right? And now we have Q and R, which probably have to be in the same plane. Yeah. So this is not drawn to scale. Q and R are probably here. I don't know. Q and R maybe. And then let's say they connect each other like that. So they're there. And then what else? Um, we want to find a normal vector. That's what we want to do. So I'm just gonna write that stuff down. So we want to find a normal vector. Let's just say that's n. So how do we do that? Well, our normal vector is kind of like this. So it's perpendicular to the plane, right? Oh, look at that. What we can do is maybe find a normal vector to here, right? How do we do that? Well, we can say we have a vector PR and we have another vector PQ. And if we get their cross product, we get that vector. We get this thing, right? I think that was in our discussion somewhere. I totally forgot. Yeah. Honestly, I'm just practicing this, but it seems pretty interesting, like some of these concepts. Anyways, so where was that? The find equation given three lines there. We have 3 points, 3 lines. We have 3 points here, and yeah, we can find EQPR, and then that gives us the vector that's perpendicular slash orthogonal. And if we looked at our previous discussion on, oh, you can't switch notes. That's funny. Oh, there we go. Calc 3. Okay. If we look at our cross product here, and we get like a nice visual, where is that? There we go. We get A and B, and their cross product is this red thing, which is exactly what we need, right? Because if you look what our problem is, right? Where was it? Here, right? We have our, let's just redraw this thing. We have P, let's say this was P, R, it's not drawn to scale, Q. What we need is this vector that's perpendicular. I'm just drawing it in a similar way to the diagram, which will give us the normal vector for our plane, right? So that's what we want to do. Actually, I shouldn't have stopped that. Yeah, this was a good drawing. For once, I actually did something good. Okay, okay, so I'm gonna redraw that thing because that was nice. So this is P. I'm gonna say this is P. This is R. This is Q. And then I'm gonna say, oh, that's that normal vector N perpendicular to vector PR and vector PQ. And so we want to get the cross product of PQ and PR to get this vector N. So that's what we want to do. I'm gonna put the visual here and let's just go straight at it. So N is PQ and the cross product of that to PR. Now we have yet to find PQ and PR. So that's what we want to do first. So let's not get ahead of ourselves. So PQ is just the difference of their components. I underlined the wrong thing. Their X, Y, and Z components. So from P to Q, how many units do we need to take? Well, from 4 going to 5, we need 1 unit. So we just subtract basically. And same goes for Y and Z. So we got 5 minus 4 is 1. -8 minus 1 is -9. and 6 minus 4 is 2. Note order matters, because if we do it the other way around, then that's Q going to P. That's different from P going to Q. Yeah, I know it sounds weird because you go like from, let's say, Seattle to Bothell, going back from Bothell to Seattle should have the same changes. But math is weird, so anyway, that's why we get the absolute value of everything, but not in this case. Next, we want to find PR. Should I call like vector PR or something? Vector PR. Okay, so this is -4 minus 4, so that's -8. -5 minus 1, so that's -6. 1 minus 4, so that's -3. And there you have it. Now we have our um, two vectors. And now we can just do a cross product. So it's from a previous video, so I encourage you to please watch it if you haven't learned about cross products before. Okay, so this is 1, -9, 2. Yeah, the idea here is we're just gonna get the cross product, we got our vector n, and then we're good to go. Because we already have our initial point, then we just plug it in the formula, and then that's it. So I'm gonna get the cross product. Making it easy for myself here. So I'm going to take out the I. -9 times -3 is positive 27. Oh, don't know why I erased that. And then 2 times -6 is -12. So this is +12. And then now we go to the J. 1 times -3 is -3. -8 times 2 is -16, so +16. Minus -16. So it's +16. And then for K, 1 times -6, -6, 72, positive. And there you have it. Now we just need to find the vectors. So this is 39. For once, I'm not doing a calculator. 7 plus 2, 9, 2 plus 1, 3. Minus 16 minus 3 is 13. Minus 13J. Oh, there's a minus. So this is -78. Okay. And so we have our vector, our perpendicular vector. Done. What a big number. Anyway, so yeah, that's our number. I didn't mess up, no? I don't think I, no. Okay, maybe I mess, no, I'm just scared if it's a big number. Anyway, we'll try it out and see what happens. And then now we just, again, use the formula. So we look at this formula here. So this is 39x minus x naught. So let's use P, -4 minus 13y -1 minus 78z -4 equals 0. That's it. Right? Yeah, because it's -4 -1 -4. Yeah. So that's it. We're done. That's the equation of the plane. We can simplify if we want to. We can further expand this. But I think I'm gonna leave it at that. Why? Because I want to. Don't need to expand it in this case. At least not yet. So 39 times x minus 4 minus 13 y minus 1 minus, keep getting minus, huh? Minus 78. Okay, cool. Z minus 4 is 0. Wait, did I get my numbers right? Hope I didn't mess up anything. 5, -8, 6, -4, -5, 1. Okay, I'm a bit sus because it's a very big number. And let me double check. Did I do my cross product right? 27, 12. So it's positive, negative. That's why it's positive, because minus -12 is positive. I take out the j, I get -3 minus -16, so that's positive 16. And lastly, we take out the k, so we have 1 times -6, -6, 70, positive 72, so that's minus positive 72. So we get that 27 plus 12 is 39, -3 plus 16 is positive 13. We add the minus there. And then this is just negative in its entirety. So this is -78. Then we just get that vector, put in the formula, done. Okay, now I was just double checking. Let's hit submit, see what happens. If I get it wrong, it's probably some computation. Okay, go ahead. Okay, next. What's this? It's like a visual. So we want to use, intercepts to help sketch the plane. Oh, so we're given a plane, an equation of a plane, and then we want to get their x, y, and z intercepts to help sketch that plane. So what plane equation are we given? Well, we're given 2x plus 3y plus z equals 6. And so we want to find x-intercept, y-intercept, and z-intercept. So first I'm going to find x-intercept. So what does it mean to be on the x-intercept? Well, it just means that to be in here, our y and z are 0 in 3D, right? That's what it basically means. So we're saying any of these points is just some x, but y and z are 0. And so if y and z are 0, so here we're going to say y and z are 0. We're going to apply that. So 0, 0, 6. And so we get x is equal to 3. Because we got 2x equals 6. And so divide both sides by 2. We get 6 equals 6 divided, x equals 6 divided by 2. We get 3. So that's our x-intercept. Let's find our y-intercept. This is one of those quick problems. So to find y-intercept, we make x and z 0, right? Because to be on the y-axis, say this is the y-axis, this is z, this is x, then this point is just some y value, but x and z are 0. So that's what it means to be on the y-axis. And so we just plug that in. X is 0, 3y plus 0 is 6. 3y equals 6, so y is 2. Done. Maybe could have mental this, but anyway. And can I find z? Let's try and find it here. Find z intercept. So what is that? Well, that means x and y are 0. So 2 times 0, 3 times 0. Oh, no space. Can I plus z equals 6? Oh, z is 6. That's it. There we go. So now if we plug those numbers in, so x is 3, y is, I believe, 2, z is 6. Then you just wanna, there's like an automated graph here, which is funny. Um, oh, that's pretty cool. Okay, I'm gonna sketch the graph. But basically, if you look at it from the foreground, let's say, here we go. We have our x. Let's say it's at 3. So x is at 3. Just say that's 3. Y is at 2. So probably here. Z is at 6. So probably here. And so a plane that probably goes through all of them is, we can't really like trace them here. Probably like there, but a bit slanted-ish. But the idea is that this 3 points here are all in the plane. So you can locate them in this plane. Okay, God, my shading. That's pretty much it. Yeah, I'm gonna erase that because it's not good. But yeah, if you kind of twist the graph around, you can see that you get a plane, and you get to see that all those 3 points, 3, 0, 0, 0, 2, 0, and 0, 0, 6, are in that plane. So that's that. Hopefully. I think we got that. Let's see. No, nice. Okay. Okay, now here's where we get to the more tricky parts of the problem. So for our next one, we want to find the cosine of the angle between uh between planes. And what are the planes? Well, we have x, y, z, which is 0, and x plus 5y plus 3z equals 5. Now, usually I prefer visuals, but this is really hard to visualize for me. So here it's not about finding an equation of a plane. This one is finding the angle between planes. So what does that mean? It actually means that both of these things intersect. So these two planes intersect. So one plane is, I don't know, like that. Another plane is like this. And so they intersect, right? This can be longer actually. Oh shoot, messed up the drawing. One could be like that. Another one could be like that. So they intersect. So that's, let's say P1 and P2. I don't know. Let's do that. Let's say P1 is this thing, P2 is this thing. Now, what other information are we given? Well, we're actually given that they're normal vectors. So the normal vector of the first one, so I'm going to say first, maybe we can do something about their normal vectors. And let's say that, we'll do n1 and n2 because we have two planes. So let's say n1 is actually just these things. So the normal vector of the first plane is 1, 1, 1. while the normal vector of the second one is, well, this thing. Just check the numbers here. So that's 153. So far, so good. Kind of. Okay. So what does that mean? Well, we can say that, oh, let's say we have a vector that goes up there. Then we have another vector that goes up here. Uh, like that. Oh, would you look at that? They have an angle here, theta. And guess what? There's a property that says that angle is similar to this one. They're similar. And so now we want to find the cosine of that angle. Oh, look at this. This vector right here, this is n1. That looking like vertical thing. That one's n1. And now look at this slanted one here. What's kind of slanted? It's actually not drawn like that. I think it was like, I don't know, like this. Yeah, it's vertical to that P1, so it's kind of going up. But that's the other uh, normal vector, so that's n2. And now if we were to look at it from another perspective, so if we were to look at this from another perspective, we can say that, oh, n2 and 1. Then we have our angle here in between. Now we actually have a thing here. How do we find theta? Well, we have a property here that says, oh, let's say we're given A and B. We have an angle. Well, the dot product of these two vectors is the length of A of one of the vectors times the length of the other vector, or magnitude, whatever, times cosine of theta. And that theta is referring to this theta. And from there, we can actually find the cosine. So from here, we just have to solve for cosine of theta. We don't have to solve for theta. We have to find cosine of theta. Right? So let's actually apply that. So this is just using dot product, basically. And so how do we do that? Well, let's apply the formula. So we get the dot product of both normal vectors, which is equal to the length of one of them times the length of the other one, cosine of theta. And then from here, we solve for cosine of theta. So what is the dot product of n1 and n2? Well, that's just the two vectors that we have. So we have 1, 1, 1 times 1, 5, 3. And so this will give us 1 times 1 plus 1 times 5 plus 1 times 3, which is 1 plus 5 plus 3, which is 9. So that's that. Now what's the length of the first one? So now here we're just doing it step by step. We're filling in the parts that we do know. So what's the length of n1? N1 is just distance formula. 1 squared plus 1 squared plus 1 squared. So this is 1 square root of 3. What else do we know? The length of n2. You can do the same thing. This is 1 squared, 5 squared, 3 squared. This is 1 plus 25 plus 9. See, let's run that up, the arithmetic. Square root of 35. Yeah, this is, let me check. 25, 9. We got square root of 35. I don't think we can simplify that, no? I don't think so. There we go. And now we can plug that in. So we have 9 equals square root of 3 times square root of 35 times cosine theta. And now we can say, oh, this is, we actually multiply those two. So we have 35 times 3, we get 105 cosine theta. So cosine theta is actually 9 over square root of 105, right? Now is that it? The cosine of the angle. Um, I think this is it, but it's not like in degrees or anything, which is totally weird. No, actually, no, this is it. Because it says find the cosine of the angle. It doesn't say find the angle. So I believe this is it. I'm gonna check. Might be wrong. Not confident. 9 over square root of 105? Question mark? Let's see if we got it. If we don't, then cool. We're gonna read about it. And I'm gonna answer it. Let's see. Fingers crossed. Oh, it's right. Oh my God. Okay. 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 Cool. Cool, cool, cool. Okay. Okay, I'm ouch. Okay. Now let's do number 6. I think we have a couple more, but no, actually we only have like what? 3 more items? Yeah, we can do that. Number 6. Here we wanna determine whether planes are parallel. So we're given planes. They're parallel or they're perpendicular. If they're perpendicular, it means they intersect at 90 degrees or none. So none meaning they're probably, I don't know if that's a thing. So if they're not parallel and they don't intersect, so there's skew lines if you're given lines. So does that mean if they're not parallel nor perpendicular, then there's skew planes? I don't know. Anyway, I don't know. You guys can tell me. Okay, so the two planes that we're given are, let's say, one is through this equation, 9x plus 36y minus 27z is equal to 1. Another one is negative 15x plus 30y plus 35z is 0. And now we want to check if they're parallel, they're perpendicular, or neither. And if it's neither, then we want to find the angle between them. So like the one we did before, but this time we're actually gonna solve for the theta. Okay, so let's see. So this is first we check. Actually, the simplest one to check is if they're parallel. Check if they are parallel planes. The easiest one to check. How do we know they're parallel planes? If they're parallel, then their normal vectors are pretty much the same. The same or similar. One could be longer, one could be shorter, but they have the same direction. Their distances could be different, but they have the same direction. Okay, let's check that real quick. Actually, we can just check that right now. This is 9, 36, negative 27. So let's say, actually, let's put some names here. I like doing names. Makes it easier. I'm gonna say this is P1. And then I'm gonna say this is P2. And I'm gonna say P1 has normal vector N1 with 9, 36, negative 27. So we're just looking at those numerical coefficients. P2 has normal vector. Yeah, also another reason why I put names, just so that's not harder to see. Has normal vector N2, so negative 15, 30, 35. Right? Now, are they parallel? I mean, you can check. I mean, there's no harm in not checking. So let's check. Let's say 936 negative 27 is equal to some k of the other vector. So let's check. So 9 is equal to negative 15k. So k is negative 9 over 15. Can we simplify that? I don't think we... Oh, we can. I'm kidding. So we can divide it by 3, actually. Yeah, negative 3 over 5. Now let's check the other one. Is it the same? So this is 30k, I believe. So let's see. K is 36 over 30. Now I can divide them by... I can divide them by anything. I can divide them by 6. If I divide them by 6, I get 6. I get what? 5. Nope, they're not similar. They're not similar. I can even try the other one. It's negative 27. Hopefully I wrote it right, no? Negative 27, 36. Yeah, okay. So negative 27, 35. Okay. So we have what? Negative 27 over 35. Immediately, actually, I kind of already knew because this was positive while the other ones were negative. Let's see this. I can divide this by can you divide this with? I don't know. Just use my calculator. Oh, you can. That's it. I was thinking of 3, but then 35 or 9. No. So k's are not equal, meaning not parallel. So they ain't parallel. They're not parallel. Now let's check if they're perpendicular. How do we check that? Wonder how we check that actually. I'm also questioning it. Well, I guess one thing we can do, say we have a plane. Another one could be like this. And so their angle is 90 degrees, right? One thing we could do, and I think this is funny. Um, we can check their normal vectors, actually. Yeah, we can check their normal vectors. This is kind of funny. Uh, this one, that's the normal vector for, let's say this is P1, this is P2, and then the other normal vector is like pointing out like this. So let's say this is N1, N2. What do you notice? Well, this goes up, this goes here. What does that mean? They're perpendicular. So we're gonna check if N1 and the dot product of N1 and N2 is 0. That's the only way to check. No, I'm kidding. I don't know if that's the only way. That's how I would do it though. Yeah. If two planes are parallel, then they have the same normal vector. If two, and therefore, maybe, if two planes are perpendicular, then their normal vectors are perpendicular also to each other, right? So I haven't even read the textbook. I don't know if there's a thing. I just guessed it. Did we solve anything like that or no? Perpendicular. Let me check. It's mostly just intersecting and stuff. Or yeah, planes, um, perpendicular right there. You have a formula for it. Uh, Cross product. Yeah. Find the find the point. Can't really tell. Yeah, this is the other problem, right? Where you had to use uh the dot product to find the angle. Symmetric? No, I don't think there's. Oh, both. Oh no, but this is the intersection of two planes. So the normal vectors of those two planes is perpendicular to that line. That's what we can say. The distance? No, I don't think so. Yeah, we haven't talked about it. Yeah, I haven't seen it in the textbook, dude. Yeah. So I'm gonna say N1. Yeah, you know what, let's do it. Is it equal to zero? So let's actually try. We have N1, which is it's a big number. 936 negative 27. Let's see. My brain thought that. That's weird. Negative 15, 30, and 35. Negative 15, 30, and 35. But if there's another way, please do tell me. The drawing, I think one way of doing math is drawing visuals, which kind of helps me like see things this way. I'm actually gonna and one and two, right? Hmm. So now let's actually try. So this is we're just doing dot product here. Plus, I'm not super confident this is gonna work because it looks kind of long. Is it? Oh no. Let's see. 15. So we have negative 135 minus, oh, big number. 180. Oh no, it's not. So it means they're not perpendicular, maybe? And here I was so proud I made up something new. Not equal to zero. That's definitely not equal to zero. Uh, I am okay. Let's see. Yeah, I'm gonna log the watch thingy. Okay. How do I check if they're yeah. Okay, I got their vectors. Okay, they're not standard. Oh, so yeah, the video I watched did the same thing, which is funny. Um, but yeah, I mean, if they're not, yeah, no, they're not perpendicular. We checked. This is a very big negative number right here. So it's not perpendicular. Yeah. So it means they're neither. Yeah. So it means they're neither. Okay. I'm going to stop the video here and I'm gonna be doing more exercises in the next one because I don't want to keep it too long. So yeah, I'll see you guys in the next one.